Okay, good afternoon.
Good afternoon, teacher.
Good afternoon.
Last week we started with the projectile motion. We said that in chapter 4 we deal with a one-dimensional motion. We talked on horizontal motion, like the car is moving, and a vertical motion, like there's an object falling down or rising up. In this chapter, we will talk about projectile motion. If we have a motion which will be resolved into two components, x and y, that's why we talk them two-dimensional motion. Projectile motion, it's like this. There's a ball, and this ball is thrown up. So it can be reached the highest point until it goes down. Now, look at the direction of this ball. It goes like diagonal here. It comes like a diagonal. This one here is a vector because it has a magnitude and it has a direction. So here now it goes with a vector upward with this direction of the diagonal. So because of that, this is now a components, or we can say it is a vertical components. It is a component, it is the velocity. Here now we have a velocity. So this is, since we have, this is the direction of the car, let's name that this exponent of this vector is a velocity. Since it's going to be up, it has to be resolved into two components, Vx and Vy. So here, if there's a ball, and this ball, it moves in this way. It didn't move to the horizontal or to the vertical. It's moved to this way with an angle from the x-axis. This will be the velocity now. For this now, this component of velocity, since it is a vector, it must be resolved, okay, into two components. What does it mean? That means this is the V, and it has to be resolved into. Since it is on the x-axis, it will be resolved here and here. It will be Vx and Vy. So the velocity here, the vector of the velocity, it will be resolved into the Vx and the Vy. The Vx, we called it a horizontal component of a velocity, and Vy, we called it a vertical exponent. The vertical, sorry.
Now we are in
component of velocity. So here now, this is the movement of the ball. So if I want now, since it is a vector, it has to be resolved to Vx and Vy. It must be rewritten into Vx plus Vy. So I will say now that the vectors V, or the velocity V, it has two exponents, Vx plus Vy. In the chapter 4, if you talked about horizontal, you only found the velocity on the x-axis. And if you talk about the object that is falling up, rising up or falling down, you will write the v of the y-axis, or we find the v of the y-axis. Here, it's not b, either on horizontal or in vertical. So I will rewrite now this velocity into two components, vx and vy. Is it clear?
Yes. This angle is vector because we have directions on it. Right?
Yes, here it's not, let's see. Here, the previous one, like you have a car, sorry, what I wrote here? We have a car, and this car, it moves on the x-axis. You will all find, when you say velocity, it's mean v of x. And you say that the velocity here is the distance over time. And if there's a ball that's falling down and you want to find the velocity, you will say also it's a distance over time, or v or 8 over t squared, and so on. This is vx and this is vy. It's only in one direction. The car, it's going to be to the right or to the, I mean, in horizontally, and the ball, it's going to be vertically. In this one here, we call them projectile motion. The projectile motion, what does it mean? That means the ball following this path. It didn't go horizontally or vertically. Like you throw a ball up and it goes down. This one, we call it a projectile motion. In the falling object, that you fall the object up in a straight line, or you raising it, you're falling it down or rising it up in a straight line motion, or a straight line. Here, no, here with an angle. Like, imagine that you have a ball, you didn't throw it up. Here you throw it with an angle. This one that we throw the ball with an angle, we call them projectile motion. And since the ball is moving here, so this will be the vector of the velocity. Before that, this is the vector of the velocity, and we name it with Vx. And for this one, we name it with Vy. But here, I cannot say it is Vx, either Vy, because it's go to the horizontal or the vertical. It's gonna go to this direction. So because of that, I must rewrite it into, or I must resolve it into two components. I will say that the V is Vx plus Vy. This is the meaning of resolving the velocity. I will write it into two components, horizontal and vertical components, Vx and Vy.
Teacher, why did you make it a plus, but the other one you make it minus?
Where minus?
The other one that you...
No, it's plus.
Okay.
There's no minus. Vx plus Vy. Now, from where we... now, this is for the first step. Now, I need now to find the Vx and the Vy. How can I find them? Okay, this is a way. How can we write the exponents? With a horizontal plus vertical exponents. Now, let's learn how can we find the vertical exponents and how can we find the horizontal exponents.
Teacher, you mean components?
Yes. أنا لسه معلقة بجرادات. Sorry, component, not exponent. So now, this is the ball. This is its velocity. As I told you, it will be resolved into Vx into Vx and Vy. Vx on the x-axis and the Vy on the y-axis. Then, so the V here, it can be written as Vx plus Vy. Now, let's know how can we find the vertical components and the horizontal components. The horizontal component, which is Vx. Here, I told you that we throw the object with an angle. This is an angle that is included between the x-axis and the direction of the throwing. So, for the Vx, to find it, I will say it is V cosine the angle. So, the Vx, the horizontal exponents, it can be written as V cosine the angle. And Vy, it is V sine the angle. So to write, so I told you that the V is the vertical plus the horizontal exponent. The horizontal exponent, it is Vx. Every time, if you talk about the horizontal Vx, you must write the cosine of theta. And if you talk about the V of y or the vertical, you write the sine of theta. Cosine with the Vx and the sine with Vy.
But teacher,
Yes.
is what do you mean about V sine? The V here.
Where?
Like, what do you mean about V sine? Like, is it V, the number of the V, times the sine?
V of what?
The equation that you wrote, V sine. Do you mean here that the number V times the sine?
Yes, V, yes, the magnitude of V times the sine of the angle. You will find V of y. And the magnitude of V times the cosine, you will find the V of x. So after you finish, you find V of x and V of y, you can tell me that the velocity, it can be written, as I told you, Vx plus Vy. So you can say it is V cosine theta, which is Vx, plus V sine theta, which is Vy. This is a way now, how can we resolve the velocity V into V cosine plus V sine. Now,
Is it written in the book? Because if it's not, I will write it.
in the book, I think no. I didn't remember actually.
Okay.
Actually, I didn't remember. No. So okay, I will send to you the this is the booklet I have from the last year, and I have some explanation here. I will send them for you.
Okay. Oh, teacher, it's from the booklet because we have the booklet.
No, yeah, but this booklet is the same from the book, but I add to them.
Oh, okay, teacher. Okay, thank you.
Okay, you're welcome. So here, how can I write the velocity? It is V cosine. This is for V of x, and this is for V of y. Now, the things that I told you before, that's when you in the previous lesson, when I told you that if you have V end of x or V here and V up, and we say that they are perpendicular to each other, to find its magnitude, what I told you, that this is the diagonal, this is V, and you told me that you have to use the Pythagorean theorem. And to find its direction, you will say it is tan inverse of Vy over Vx. This is, so the first one in the before in a few minutes, what I told you that if you have V and I want you to write Vx and Vy from V, you know V, and I want you to write Vx and Vy. Here, no. Here you know Vx and Vy, and I'm asking you to find V. What you have to do? You have to use the Pythagorean theorem, which is square root of Vx squared plus Vy squared, and then we have also to find the angle, which is tan inverse of Vy over Vx. They are opposite to each other. In the first time here, the first one here, I give you, you know what is the V and what is the angle, and you find V as V cosine theta plus V sine theta. And you can find Vx and Vy. So here I give you V and I give you the angle. And I want you to write the exponents, the components of V. And the second thing here, that if I give you now the Vx and the Vy, it is the opposite. And I asked you now to find the V and the angle. How? I will say now V is the square root of Vx squared plus Vy squared. And to find the angle theta, you will say it is tan inverse of Vy over Vx. Is it clear now?
Yes. Yeah.
Yes.
Yes, teacher, but it have like many formulas.
Sorry?
It just had formulas, a lot of formulas.
Yeah. Now let's have an example here.
Teacher, today you are going to send these formulas?
Yes, after this period. A ball is rolling on a flat table degree at a stable, at 15 degree from direction parallel to the bottom edges at speed 7 meters per second. Here now there's a ball. It's rolling on a flat table at 15 degrees from direction parallel to the bottom edge at speed 7. So here he gave me the magnitude of the velocity, which is 7, and the angle, which is 15. And I want you now to write, when I also ask you to find, so I will write it here like this, find the horizontal component and find also the vertical component. Yes?
Teacher,
Yes?
I'm sorry. I don't know what happened to the internet.
Okay, Sarah, there's no problem. So now,
Teacher, but you don't have this, you have just speed.
this is the speed V and the angle 15. That's only what I need, the V and the angle. So let's find now the horizontal components. The horizontal components here, if you want to find it, and first, let's draw. There's a ball, it's thrown up with a degree of 15, and its value here is 7 meters per second. So if you want now to find V of x, V of x, it will be V cosine the angle theta. V, which is 7, times cosine the angle, which is 15. Now be careful. If I give you the angle here, like 75, you will not write cosine 75. You have to find the angle that's included between the projected motion and the x-axis. So this theta is only this angle between the x-axis and the projectile motion, or the projectile object that is a projectile. This is the angle will be only. So you say now cosine 15 times 7, which is 6.8 meter per second. This is now the v of x, the vertical component.
So teacher, the degree here, it is the angle.
Sorry?
So 15 degree is the angle.
Sorry, Rose?
Teacher, I say that, so the degree here, 15 degree, it is the angle between these sides, because it's
Yes, between this, the object that is projectile and the x-axis, not with the y-axis. You have to find the angle first. If I give you as an example, it is 75, you have to find 15, then you write the horizontal component. Then the second one, you have to find now v of y, which is v sine theta. What is the value of v here? It is 7 sine 15. If you add them, you will find it is 1.8 meter per second.
But teacher, the one who says that if you give us 75 like that, how we can find the angle?
Sorry?
Like the one who says that if we have 75, how we can find in this case the angle?
By subtracting 90 from 75. Here, it says that the Vx and the Vy, these two components are perpendicular to each other. They have a right angle between them. So if this is 75, here it will be 15. It's math.
Yeah.
Okay, now, if you try now to find, here you will stop. But if you want now to find V, okay, as an example, okay, I know that is 7. I want to prove that it is 7. What I tell you to do, I tell you that you have,
make 6.8.
yes, you will find the square root of
the
v of
x
squared plus v of y squared. Let's do it. Square root of 6.8 squared plus 1.8 squared. Try it now in your calculator if you have 6.8 squared plus 1.8 squared. The answer is 49.48. The square root of the answer, it will be 7.03. So, which is 7.
Yeah.
And if you try now, also tan inverse of where's tan inverse? Okay, tan inverse of 1.8 over 6.8, you will find that the angle is 14.8 or A15. That's it. So if I ask you to find the horizontal components, you will say it is V cosine theta, and the vertical, you will say it is V sine theta. Cosine with the x-axis, sine with the y, with V of y. Be careful that the angle, it must be included between the x-axis and the velocity component, or the velocity of the projectile object.
Can you tomorrow make a lot of some of the complicated questions like that?
Sorry?
Tomorrow, can you take a complicated questions like that? Like some of complicated questions.
Yeah, I put tomorrow we'll talk about projectile motion. Then on next Wednesday I will put some problems for you like this.
Okay, teacher.
Yeah, now
so
let's
tomorrow
try.
we're going to take a new lesson.
Yeah, now I'll give you another example. in this one here, where is it? A cyclist heads due west on a straight road. The wind is blowing from 248 at, so let's write them here. Cyclist is due west on a straight road. So he driving his bicycle on a straight road. Then there's something happen. The wind is blowing from 248 degrees at 10 meters per second. So here now, this is a road. And he, or the wind is blowing them 248 from the x-axis. From here, it's gonna be 248. What does it mean? Here is 180 until here. This is now the vector of his velocity, which is 10 meters per second with an angle of 248. Now,
So what is 248?
from where I bring it?
Yeah.
It's here.
No, like what it is, like how do you know that it is an angle or what?
Here, I must written here a degree, 248 degree.
Oh, okay.
So it's blowing now from 248 degree. Now, I want now to write the horizontal and the vertical components. The Vx now is, now, I want to use something here. Wait, please. Now, let's go back to math. In math here, inshallah, we'll talk about it in chapter 14. This is quadrant 1. This is a quadrant 2. This is a quadrant 3. And this is quadrant 4. Now, all of us know that in quadrant 1, both of the sine and the cosine is positive. In quadrant 1, both of the sine and cosine is positive. And the tan also, it will be positive too. That means any angle in quadrant 1, its sine or cosine or tan, it has a positive magnitude. In the second quadrant, here the sine is positive and the cosine, it will be negative. Like as an example, try cosine 100. You will find that sine 100, it has a positive number, but cosine negative, cosine 100, it has a negative number, a negative magnitude. For the third quadrant here, you will have, or you see that both of the cosine and sine has a negative magnitude. And in the last quadrant here, the cosine, it will be positive, and the sine, it will be negative. In the first quadrant, both of them are positive. In the third quadrant, both of them are negative. In the second quadrant, the sine is positive, and the cosine is negative.
So what about the tan?
Wait, please. And for the fourth one, a cosine, it will be positive, and the sine, it will be negative. Now for the tan, here, the tan, since the tan, as I told you before, it is sine over cosine, so the tan here is negative. The tan here, it's also negative, but the tan in the first quadrant is positive, and the tan in the third quadrant is also positive. So the tan, it will be positive in the first and the third quadrant, and it's negative on the second and in the third quadrant. The sine, it will be positive in quadrant 1, quadrant 2 only. And the cosine, it will be positive in the quadrant 1 and the quadrant 4 only. Okay?
Yes, teacher. Like you mean it will be negative tan. So if we have like 2 in the tan, we will make it negative 2.
Sorry, what did you mean? What's negative 2?
Like you mean when we are going to make the formulas, we will make it negative tan. Like if it's we have the number in graph 5 or 4, yeah, 4, we will make it negative tan in the formula.
No, not negative tan. No, I just tell you that because as an example, take here if it's 270, take as an example sine 300 in your calculator now. Sine 300, it's negative square root 3 of 2, and cosine 300, it's 1 over 2. So the tan, I told you that the tan, it must have a negative sign. Here, as you see here, it's negative 3. If you try it on the calculator, you will find that it's negative square root.
Yeah, it is negative.
Right. Now, why I tell you this? In this case here, as I told you, you have to find the vertical and the horizontal exponents. The vertical exponent, it was V times cosine, the angle here, and the Vy here, it is V sine the angle theta. Then, what is the value of V here, or the value of tan? The value of the velocity, it is 10.
10.
It is 10 times cosine 248. Then, by calculator, you will find that cosine 248 is negative times 10. So the answer here is negative.
Oh, teacher, it is negative.
And for the Vy here, you will say it is 10 and then sine 248. Then sine 248, it's also negative, times 10, it's negative 9.2 meter per second. This is now Vx and this is now Vy. Now, what I want to do now, and here, it's easy for me because the angle is started, included between the x-axis and the object here. Now, what about if I told you now that the angle is only, I give you that the angle here only, which is 68. Okay, here the angle is 68. Shall I continue now or tomorrow?
No, teacher, let's continue now.
Because the period will finish after 2 minutes.
It's okay, we can complete tomorrow.
Okay, I will give you the idea now, and tomorrow I will repeat it. Here now, if you have a 68 and the 68 here, you have the same one, but now the angle given here only, and the velocity here, it is 10. If you now, you remember that both of the answers is negative. If you want to write now the Vx and the Vy, you say it is 10 cosine 68. And here it is 10 sine 68. And if you try cosine 68, okay, you will find that the answer is positive. Try it now in calculator. You will find the answer is a 3.7. But when I found it as a whole angle 248, the answer is negative. So there's something wrong. When you tell the calculator this cosine 68, the calculator cannot know in which quadrant you are talking about. Are you in quadrant 1, or in quadrant 2, or in quadrant 3, or in quadrant 4? But you, because you are in grade 10, you have to know that in the quadrant 3, both of the sine and the cosine are negative. So what does it mean? That means after I write this answer, since I'm in quadrant 3, I will put the sign here as negative. The calculator didn't know. Okay, the calculator can help you mathematically, but it cannot solve everything. That's why we study math. Cosine 68, if you try and type the calculator, it will give you positive because you didn't know in which quadrant are you now. But since I am in the quadrant 2, the quadrant 3, and both of the sine and cosine are negative, so here I must have negative 37, and down I must have negative, because there I'm in quadrant 3, since now sine 68 times 10, it is negative 9.2. And the same if you have the angle here and the angle here. You must know where the sign is positive